In today's video, we're going to take a look at solving simultaneous equations or systems of equations by elimination, and this is going to be part 2 of solving systems by elimination. So taking a look at this first example, remember in the last video we talked about how we want to make sure that the variable, so the coefficient in front of the variable, is either the same number or the opposite. But if we take a look at this one, see how we have negative 6x and this one has negative 2x. And this one has 5y, and this one has negative 4y. Neither of the coefficients of these variables are the same number, so what we're going to have to do is we're going to have to multiply. And ideally, we want to multiply it so that we only have to maybe do it to one equation and not both. So I'll show you what we mean by that. So equation 1 and equation 2. So if we just copy this, let me take this look here. So what I mean by that is, if I look at the first equation, and let's say I'm looking at the variable of the y. And if I look at the variable of y, I've got 5 and 4. So what we want to do is think of the LCM of 5 and 4. And the LCM of 5 and 4 is 20. So I can multiply this first equation by 5 times what makes 20? Well, that's 4. And for the second one, 4 times what? That makes 20. That's 5. So I'm going to multiply that one by 5. So we're going to multiply both of our equations so that we can use the elimination method. So if I multiply both equations, I'm now going to have the equation, it's going to be negative 6 times 4, which is negative 24x, and then 5y times 4 is going to be positive 20y, and 25 times 4 makes 100. Now I'm going to have to do the second equation, and negative 2x times 5 makes negative 10x, and then we get negative 4y times 5, which gives me negative 20y, is equal to 14 times 5 is 70. So now that I've multiplied both equations by 4 and 5, I still have that this is equation 1 and this is equation 2. And now what we see is that both of the y's have the same number, just opposite signs. So now we can use the elimination with these equations instead. Now, that is not an incorrect strategy to solving this problem. We could definitely multiply both equations, and sometimes we have to multiply both equations. However, it's not the most efficient method or strategy. So let's just take a look at, instead of the y variable, let's take a look at the x variable. So I just copied that equation again. And when we look at this one, when we look at the x's, I've got negative 6x and negative 2x. Well, if we think, what's the LCM of 6 and 2? Well, that's 6. So this one's already 6. So what's nice is I don't have to actually do anything to the first equation. What I do need to do is something to the second equation, and then it's going to be to multiply it by 3, because negative 2 times 3 does make 6. So the first equation stays the same. So this is going to stay the same, so I can just copy that down there. And then I have the equation, I've got negative 6x. 4 times 3 is going to give me my negative 12y is equal to 14 times 3, which is going to give me 42. And that's going to be my equation 2. So this is the better strategy here, because I only have to multiply one of the equations and not both of the equations. And now we can see that we've got negative 6x and negative 6x, so we can solve this one using the elimination method. So now that we've decided the right strategy to use, so the one that's more efficient, let's just go ahead and look at using strategy number 2 to solve this problem. So since we have negative 6x and negative 6x, we're going to now decide, are we going to add or subtract our two equations. So what we can see is that they both have the same sign, so we could subtract. Since negative 6x take away negative 6x is the same thing as saying negative 6 plus 6, which is going to give us 0. So now the second part is, should I do equation 1 take away equation 2, or equation 2 take away equation 1? Again, you want to do what's easier for you. So for myself, I'm going to do equation 2 take away equation 1, only because 42 take away 25 is a lot easier than saying 25 take away 42. So what I'm going to do now is I'm going to rewrite my equations, because I want to put the equation 2 on the top. So negative 6x minus 12y is equal to 42. And I've got negative 6x plus 5y is equal to 25. And we're going to subtract our two equations. So just put a subtraction sign there. All right, so now we've got negative 6x, take away negative 6x. Well, that's going to give me 0. So this is going to cancel out. Then I've got negative 12, take away 5, which is going to give us negative 17y, is equal to 42, take away 25, which gives us 17. So we can divide both sides by negative 17. And we get y is equal to negative 1. So we've got one of our numbers we need. So now we can substitute this equation into the original. So what I'm going to do is look at the original, so these originals, and pick the one that's going to be a little bit easier for us to work with. They're both, they both have to be multiplied by a number. Y is multiplied by this, and the y is have to be multiplied by this, the 5. So in this case, they're both kind of probably about the same level of difficulty. So I'm just going to choose 2 only because this number is smaller. So I've got sub y is equal to negative 1 into my equation 2. So negative 2x minus 4, and instead of y, I'm going to have negative 1, and that's equal to 14. So I've got negative 2x. Now here is a little part we have to keep in mind. Negative 4 times negative 1 is positive 4. So this is now going to be plus 4 is equal to 14. And now we can solve for x. So take away 4 to both sides. This is going to cancel. We're left with negative 2x is equal to 10. Divide both sides by negative 2. And we get that x is equal to negative 5. And we can give our answer as an ordered pair. So we've got negative 5 and negative 1. And we can use Desmos to double check our work to see if we're correct. Or we can substitute these values of x and y back into our original equation. So the x would go for there and the y would go into here. So I'm going to use Desmos just because it's a little bit quicker without doing more math, a little bit less room for error, and double check my work with Desmos. So in the screenshot from Desmos, we can see that the lines are intersecting at the point negative 5 and negative 1. So we've just double checked our work and we did this one correctly. So here are 3 questions for you to try out on your own. So for each of these, we're going to have to multiply one of the equations so that the coefficients of the variable are the same. And we do want to check our solutions. So we can check our solutions by going on Desmos and seeing if we got that correct. What I do want you to just keep an eye out on is for number 3 here, because remember in our first video I mentioned how we need things to line up. So notice that this has got 5y and a y, but we got a constant here, 15, and right underneath it is a negative 2x. So we want to make sure just that the variables and the terms and the constants, they kind of match up. So this negative 5x can't be subtracted or added to this 3 because they're not like. So we want to maybe rearrange this one a little bit. So take a moment to pause the video to try out these 3 questions. So in this last example, we're just going to look at choosing a solution method. So we want to ideally pick the best strategy to solving this one without doing more work than we have to. So our first strategy, or first train of thought, is always the first thing is, do any of the variables have the same absolute value for their coefficient? So that could be 2x and 2x because they have the same number in front too, or opposite signs, negative 2x and 2x. And if that doesn't work, our second strategy would be then, can I only multiply one of the equations so that the coefficients have the same absolute value? So our goal is if we can, we want to avoid having to multiply both of the equations by a number because it's just going to create more work than we would like, and also more room for error. So now we've got these 2 different strategies, 1 and 2. So priority is to do this one, and then if we can't, we have to do strategy 2. So if we look at this one here, do any of the variables have the same absolute value for the coefficients? So if we look at the x, I've got 1, and this one has negative 1. So they do have the same absolute value. So the best strategy would be to do this one, so that we have opposite. So we can just, from here right away, add or subtract. So hopefully we see that right away without looking at, okay, none of them don't, for example, and then looking at the 2 and the 4. And if we were to do that, well, what number can we multiply? Ideally, we want to multiply one of these equations, so we could multiply this one by 2 because 2 times 2 would make 4. Ideally, we don't want to think, oh, I need to make these two the same, so I'm going to multiply this one by 2 and this one by 4 so that they have 8y. Like, that would be too much work, and we want to avoid doing that. So with these, we're just looking at elimination and just trying to choose the most efficient method for solving. And we have your lucky day because after this example, we actually don't have any more try it questions. So you just have those 3 questions from before for your homework for this video. So take a look at those 3 again, make sure you do those, and we'll take a look at those in class. See you then.